Hi everyone, my name is Wang. I'm from Google DeepMind. I'm a research scientist, and also I'm a creator of the open source project AutoGen and now AG2. I'm based in Seattle, so when I flew here yesterday, I developed a very terrible headache, so I thought I couldn't make it here today. But here I am. So apologize for potentially low energy. So today I want to take you on a journey through where we've been and where we are and where we're heading with Agentic AI. It's kind of like a journey I want to discuss more high-level story of this entire field. When I was 7, I met my first computer, Apple II. It doesn't have, I don't know, like internet, no apps, just a blinking screen with endless possibility. I remember thinking that, okay, this program is alive, so that's the thought. And that illusion planted a dream to build AI that can learn and grow with me. Okay, so fast forward to the spring of 2023, on a quiet night during a trip to Vancouver, that voice returned. Now is the time, it says. And so many people at that time were very skeptical of this idea, but I couldn't ignore it. So I decided to drop everything else and build what I always imagined with the community that shared the same vision. So that's how AutoGen was born. It was built as a simple framework to accelerate our own research and makes our research much easier. But it evolved to be AG2, a foundation for researchers and developers working on the Agentic AI. And the journey of AG2's growth is a good reflection of this wave of Agentic AI. I created an open source project for automating machine learning and hyperparameter tuning. The name is Flammo. And although AG2 was initially just built as a sub-package for multi-agent conversation, but it quickly became something bigger. Within months, AG2 was top training on GitHub and cited in top papers, and quickly attracted tens of thousands of developers for adoption. The most fun part is to watch the developers orchestrating the agents, just like the musicians, each of them improvising and working in harmony. So users of community have used AG2 to tackle many very challenging tasks and make new records on the benchmarks like Westword for computer use, Sweetbench for software engineering, Web Voyager for web automation, etc. It was amazing to see all those milestones. They are not just for AG2, but represent the progresses of the entire Agent AI research. AG2 now powers real systems across industries. Here are a few examples, like agent platforms by Google, chip design by NVIDIA, marketing and recommendations by Walmart, web automation, emergencies, and so on. And so the same framework that helps engineers code also helps chip designers design chips, investors to evaluate business ideas, even helping farmers to track their soil health. So from training floors to farm fields, the Agent AI is changing how we work. So it's no longer just an experiment, it's a revolution. But we're still very early in this revolution. Because if you look around, I still don't have my agent that can learn and grow with me. So that I'm sure that I'm betting that I'm not the only one who want it. But I'm still glad that the AG2's influence has reached far beyond its individual use cases. It is inspiring new research, new innovation, new products, and new collaboration, new ecosystems. And that makes me confident. And also, if you look around, the whole industry has made big progresses in the past 3 years. So I'm very optimistic that we're getting closer to the North Star, and we'll evolve there eventually. And to explain this evolution, I want to walk you through these 3 key dimensions: the interface, the capability, and the architecture. Dimension 1 is interface. So today's AI is gaining sound and sight, The products like Gemini Live can use your camera to see the world around you and speak to you in real time. And the early prototypes also can see your screen and trigger actions on your side when you use your devices. So these advances narrow the gap between understanding and intent. But to reach our North Star, we'll have a lot more to do. Like, for example, context must flow across devices, and agents must know when to step back and when to step in. If we solve these challenges very well, a lot of new emerging applications, interesting applications can be enabled. So fundamentally, because the more the agents understand you, the more kind of gaps they can fill that traditionally just require humans to fill. For example, there are agents that can work while you sleep. So they fill the gap, they connect the two different versions of you, like the version before you get sleep, and then fill the gap in your sleep time and connect with you when you wake up. And there are agents that can connect devices so that no matter how many devices you have, as long as you have access to one of them, you can have access to every data and computer you have. And you just need to talk to one agent living in one device. Also, agents connecting people that fill the gaps, for finding hiding time to get everything at the same, get everyone at the same time. Let's see if we can play this video. Yeah, watch this clip and tell me how many humans are involved in this meeting, hybrid meeting.
The Nginx and Ethereum trenches, that's dope. So tell me about the vibe coders you mentioned. What's the story there? Like, who exactly are they, and what's that moment you realize they don't have the human guidance and trust they need?
Yeah, so I judge a lot of hackathons. I actually work full-time for the graph at the moment, and I find that there's a lot of coders that are coming up and showing me code base that they really don't understand. And so there's definitely a gap where like AI is going to be this kind of a crush, but something that's going to need to be filled by some kind of human mentorship. So that's why I've created Genesis to allow that to happen.
I get the appeal of on-chain mentorship and skill value. But how are you going to tackle the friction towards learners signing smart contracts, that onboarding?
External scale. Is this?
No, it should be headphones.
Headphones.
Okay. To make it feel seamless and not like a tax form.
Yeah, so my app is Privy enabled, and account abstraction is basically the next plan of attack right now.
Yeah. So yeah, can you tell like how many humans are involved in that meeting? 2, 1. Oh, yeah, yes, it's only one. So only the presenter that doing the pitch. So everyone else online, they were like an AI digital twins of some investors. So this is an application called AI Shark Tank, and it's powered by Soul Cipher. There's another very new open source project I want to share. I guess you will know immediately why the reason. Let's see if I can play.
AI agents can now reason and act for us, searching the web, conducting research, even building software. But as they grow more capable, they remain isolated, unable to discover or collaborate. What if it's not a single agent, but a network where thousands of AI agents connect, sharing knowledge and solving problems together? Introducing Open Agents, an open source framework for building AI agent networks and enabling open collaboration. Our mission is to connect agents into vibrant communities. With Open Agents, you can create and publish your own networks, or explore and join thousands already active. Found a network you love? Bring in your agents and start collaborating. The rich plugin system allows agents to work on diverse scenarios, from exchanging the latest technology, products, and news in chat rooms, to trying out products and discussing feedback in forums. As a community, they socialize, learn from each other, and grow together. Open agents, AI agents, open networks, true collaboration.
Yeah, it's I can't help like showing this because it's a project has the same name as its conference, Open Agents. And it's a very nice vision. And one related upcoming feature in AG2 is the remote agent that is compatible with A2A. Okay, so that's about the interface. And the dimension 2 is capability. So understanding is just the beginning, and the agents must act based on the understanding. And that means real capability. What is the most capable agent you think we have today? Yeah, I think different people may have different opinions, but I suppose that the coding assistants should be one of the top 3, no matter what's your opinion. And there's products like Cloud Code and Gemini CLI, Codex, and so on. They're very powerful coding assistants that integrate with your development workflows and can autonomously write and refactor code. And code is meta power, right? So it's still very much underexploited, I think, because the agents can potentially leverage the coding capability to learn, to experiment, to improve themselves, refactor and modify, and also spawn new agents, right? So there's a lot of possibility, but to realize this vision, they also need long-term memory and cross-section reflection, and just the iterative improvement. So that's how agents grow. They don't just memorize, they learn, improve through this interaction and experience. And that's also how the entire human society has making progress, for example, in science. We make hypotheses, right? And we do experiments, validate them, and we generate new knowledge, consolidate them, and that's how entire human knowledge evolve. So science is very, very nice and a testing ground for agent AI. I want to introduce a new open source project called Denario. It's built on AG2, and it automates the scientific process from idea generation to writing a science paper. And these agents don't replace scientists, but they amplify our curiosity, and they help us move from hypothesis to insights faster than ever before. And this slide highlights our amazing collaborators, scientists from Cambridge, Harvard, Google, and many more institutions across the world. And hundreds of papers have been generated in many science domains, like biology, biophysics, biomedical informatics, chemistry, planetary science, mathematical physics, quantum physics, plus cosmology, plus machine learning, neuroscience, and material science. And how good are the quality of these papers? I think there's still time to fully evaluate them, but the first paper is already accepted to this open conference of AI agents for science. Actually, I think the conference will happen tomorrow. And that's the first open conference where AI serves as the primary first author, and also reviewers of research papers. So yeah, it's been nice to check that out. And now, yeah, so that also makes me remember one fun fact that in Europe's channel, in Europe's panel last year in December 2024, there's a question asked by Jared, when AI is going to be as capable as human scientists. The answers from panelists are 3 to 5 years, 10 years, or never. But what was my answer? I said it's possible that we will see that happen in next year, which was 2025. So it's actually hard to believe how fast it is, even including myself. And it's also remember that it's not the end of just writing the paper, because it's all the research, all the kind of new technology. They're accelerating so much, but it doesn't really help you unless you can integrate them into your own repo, your own projects, right? So I'm glad that someone is working on that problem. So GitRank from Remix AI solves a real pain point that is turning the research into a usable code. And that's also built with AG2, and it turns research papers into testable pull requests in minutes. It connects the research to real-world projects, automates the testing, integrates the results. That's how we move from just reading about innovation to really using them. And dimension 3 is the architecture. In future, the breakthroughs will come from collaboration among diverse agents. AG2 orchestrates multi-agent teams. And MassGen, a very new open source project I'm going to introduce next, pushes further. It's running agents in parallel, observing and refining each other's work. And you can imagine this scaling recursively. So every new agent amplifies the performance of the whole system. Okay, the potential is exponential, but we must solve consensus, the shared memory, and interoperability. And by the way, these are some of the old challenges that also happen in the human organizations. So it's fitting that AI is facing them now. So traditional scaling laws. So like, who of you like believe that we're hitting a wall of like traditional scaling laws? Yeah. So I think it's There's some hands. So yeah, there's still some topic that in debate. I'm still hearing different opinions among the researchers. But we do see some signs that there's some slowdown, and there's a reason to think that maybe bigger isn't automatically better. But that's about inference time scaling. So inference time scaling is a good idea on the exploration. So right now there's no universal way to leverage the improvements of foundation models or agents at runtime while avoiding their limitations. So what's the way forward? A new paradigm is to do multi-agent scaling and scale the multi-agent systems. So instead of just pushing the model size, we orchestrate agents at inference time and make them coordinate, collaborate, and self-improve. The gains are real and measurable. One example is with a single agent setup, the Grok 4 standard reached the 38% score on the last human exam benchmark, and the highest when it was announced in July. Now compare that to Grok 4 Heavy, a multi-agent collaborative system. The score jumped to 44%, and there's no change to the model, right? There's only by multi-agent scaling. And it's priced 10 times more expensive than Grok 4 standard. So that's price for the multi-agent scaling technology. And there are many other examples too, like Gemini DeepThink won gold medals in both the International Mathematical Olympic competition and also the ICPC programming context. OpenAI did well too. So multi-agent scaling has been used to solve these problems at the very frontier of human computation. There's some recent research done by my colleagues from Cloud AI and collaborators from MIT that also studied even when you use the same model but configure them with different tools and different prompting techniques. There's like substantial gain on variety of benchmarks, human last exam, GBQA, that's graduate level problems, and also some mathematical benchmarks. The scaling effect, we can study like how the technology scales with number of agents, with tokens and inferences. And turns out this is this new approach of doing multi-agent scaling have a slightly better scaling effect than alternatives. But it's still very early. Like you can see that they still hit some plateau as we increase the compute. So that's very interesting kind of early exploration of this new frontier. And the MassGen, the open source project, explored this new frontier of scaling. It is built on the foundation we have been developing with the AG2's research and community. And it's only 3 months old. And the insight behind it is that just think about like how humans solve problems together. Like in a study group, different people can bring different strengths. Someone's good at math, another is good at like framing the big picture, and together they tackle problems no one could solve alone. And MassGen mirrors that dynamic. It bridges different ecosystems. So agents don't follow a static collaboration pattern. They actually learn from each other in real time, and each interaction makes the whole system better. Here's like how MassGen works. There's an orchestrator that distributes tasks to different agents. You can configure the differences with different models, different backends. closed source, open source, open weight, and you can give them different tools, like connect with MCP, can connect with web browsing, coding, and file systems, multimodal, and everything. And then all the agents can run in parallel and in an async way. And there's a shared collaboration hub that will allow the agents to post real-time updates and refine each other's work. And Orchestra will detect convergence when the solutions stabilize, and it will also use adaptive coordination to restart the agents if necessary. And here's a real example of how multi-agent collaboration leads to better outcomes than any single agent could achieve. So this is a graduate level physics questions from the GBQA Diamond benchmark. It's a tough problem, like something like even the frontier model often miss. And if you look at the initial answers, so none of these initial answers by different models, they're all the frontier model-powered agents. None of these initial answers are correct. But here's where collaboration matters. So one agent notices a major discrepancy from the answers of these multiple agents. So it instead of doubling down its previous answer, it decides to revisit the calculation. And that peer observation triggers a self-check. And the breakthrough moment is when the agent revises the answer, and eventually 3 out of the 4 agents converge on the correct answer. So the system as a whole succeeds even though each individual agent failed in the beginning. And that's the promise of this multi-agent scaling. No multi-agent reasoning. There's no perfection on the first try, but the ability to catch mistakes and correct each other and converge on truth. So that's the fundamentally kind of different kind of intelligence. And if you're curious, you can explore many other case studies at case.massgen.ai. We've seen agents co-create websites, analyze financial data, and even writing teaching material, all without human micromanagement. They're not perfect, but it's self-correcting, and that is an essential gradient in my belief to reach the North Star. Yeah, we can probably just watch one live demo and see it in action. So this is a very new case study enabled by the very recent release from MassGen. It allows the agent to collaborate and find market trends, also find the user requests on the GitHub repo, and try to prioritize which feature to develop next. So here we're using 2 agents for simplicity. I think one of them is Gemini Pro, and another is GPT-5. So we can see that each of them can use their unique tools to do the work, do the research, use coding capability to write code if necessary, and eventually they will converge. So here's like what happens behind the scene. So we can see all the agents are in parallel, so they don't block each other. So each agent can work individually using their best tools, but they don't need to wait for the other agent to finish. But as soon as some agent finishes, they will share results. They can check each other's results and decide to either vote or revise their own answer. And finally, the selected agent will represent the full group and generate the final answer. There are a lot of hard issues. Also, for example, if some actions are transactional, so you can't allow all the agents to perform that transaction. You can only do brainstorming with multi-agent collaboration and only execute that as a final step. So we're only scratching the surface, and there are still many challenges, like I mentioned earlier, regarding the consensus, regarding the context sharing and interoperability. And we need your help. So please check it on GitHub and join our Discord to work on this scaling problem together. Okay, let's bring it all together. The natural interfaces turn intention into understanding. Strong capabilities turns understanding into actions and self-improvement. And the scalable architectures allow many minds to co-create solutions. Together, these create our North Star, agent that grows with us. Thank you.